Well, welcome back from the break. It looks like some of you enjoyed the break so much you decided not to come back. By the way, just a point of clarification, I do not take attendance. But as I told you at the outset, in this course, there's identity. And I know where each and every one of you sit, and I know when you're here and when you're not here, but I'm not taking attendance. But it matters. You are identified by me. And it's not anonymous, in contrast to a lot of other courses on the Berkeley campus. Today, it's going to be very fast. In large part, I'm going to be covering some material we've already covered, and it goes directly, at least with regard to uniformly mixed fund pollutants, it goes directly to your textbook. And what I'm going to do is try to clarify a few of the major concepts. But then I'm going to move on very quickly. I'm only going to spend 25 minutes on that. If I don't finish it, I'm going to come back later and pick it up when we look at specific natural resources, whether it be water, land, food, whatever. So don't get annoyed if I move too fast because you can't keep up with your student handout notes, but this material is in your textbook. And moreover, the author of your textbook is going to be here on Thursday to make sure that you're all comfortable with the readings in the textbook for the second part of the course. In addition, I want to remind you about Thursday. As I announced before the break, there is a special panel discussion that goes to food and agriculture, and therefore major thought leaders who are going to be making presentations at Wheeler Auditorium beginning at 6:30. However, the tickets are available at 5. And if you want to make sure that you have a seat at 6:30, you should appear at Wheeler and get a ticket, because it's an instance in which there will be excess demand, right? Because there are only so many seats in Wheeler Auditorium. Okay, any questions? It's for everyone is invited. There's a number of donors that are going to be here. They will get seats, quite obviously, because they're contributing to the resources that are available for the university. But it's largely for students. But I suspect no more than half of the audience will be students. Question? Yes, I did say it will be either of the two places. You can either. My understanding is the tickets will not be available till 5 o'clock. You can get them either at G&E Hall or at Wheeler. Okay? All right? Okay. Yes.
Or at Wheeler.
Yes, that's what I said. Any other questions? Okay, Stan, we got a problem. Stan's our IT guy, in addition to everything else he does. All right, so as I indicated, we're going to talk about uniformly mixed pollutants, but we want to look at a number of concepts that we covered in the first part of the course, namely what are deadweight losses and how do deadweight losses appear in the context of public policies which are designed to correct for external costs or externalities that are being generated. And keep in mind, what's different now versus the fundamental core principles of microeconomics is there is no market price. So we can't rely on an equilibrium of willing buyers and sellers to interact with one another to come to some stationary equilibrium where each of the participants within the market are satisfied. That's no longer the case because the externalities are not priced. And all you can hope to do through public policy is to put the right value on those externalities. All right, so let's start with a simple two-firm model. And let's suppose the government comes along and says there's a predetermined pollution level that society is prepared to accept, which is 15 units of admission. And we know what the marginal control cost, and by the way, the marginal control cost is synonymous with the marginal abatement cost. And there's a marginal control cost for firm 1, there's another one for firm 2, and the intersection of the two marginal costs for each of these firms is the point at which total costs are minimized. Why is that true? It's true because the area under each of the two marginal cost curves is the total control cost that is borne by each of the two firms. Right? Let's look at this graphically. This is a little different in your textbook, but don't be confused by it. On the horizontal axis, for the first firm, we're measuring the amount reduced at admissions, which is the same metric as the amount abated. That is to say, the amount that's controlled that doesn't find its way into the atmosphere if we're talking about air quality emissions, or if we're talking about water contamination, the ambient contaminant quality in water sheds, for example. So on this horizontal axis, the amount reduced for firm 1 is represented left to right. And this is the corresponding marginal control cost for firm 1. In contrast, the abatement or control for source 2 is measured from right to left. Right? And we see that at the point of intersection, the area under each of those two curves represents the total cost or resources that are engaged in abatement. And that total cost is for first firm A, it's this area A, and for firm 2, it's this area B. Okay? We're going to complicate this chart in a moment. Let's look at a different example, and this is the one that's discussed in your textbook with lots of graphical analysis, some of which some of you have found confusing. And I'm hoping to clarify it so it's no longer confusing. The example is the cost of abating nitrogen oxides. And here is the first graph. And instead of measuring both sources of pollution on the same axes, what your textbook does is measure the amount of abatement first for the power plants that are contributing to nitrogen oxide, and they can abate, and this is the amount on the horizontal axis that they're abating, and it's measured left to right. In contrast, vehicle cars also abate nitrogen oxide, but now this is going to be measured right to left. Okay? That is the construction of those graphical analysis that appear in your textbook reading for our last lecture. And what this shows is the marginal cost for power plants clearly is very steep, and it rises very quickly the more abatement that they actually do. In contrast, the marginal cost of abatement for vehicle cars is very flat. And given the graph we just went through, if you look at this graph immediately, it should occur to you the right answer has to be 45 cents. Why is that? Why is that, or why should that be crystal clear? Jake, why? And the total cost below each of them, summing that up, is going to be minimized. Right? It's the same story. It's just a bit more complicated. And at that particular optimal solution, namely at 45 cents, the amount that's being abated by power plants is 2.7 million tons. That's shown right here. And moreover, the amount abated by automobiles is what? Speak up. 19.4. Coming right up from this point all the way up to the axis measuring the amount of abatement by cars is 19.4. And thus, if the government or the public sector's policy is to reduce and or control the amount of abatement by 22.1 million tons, that will give you the solution. And moreover, it will be the solution that minimizes total control cost. All right, cost-effective policies. As we've seen again and again, there are three standard public policies out there. One is to set a standard. And what are the problems with, what are the limitations with regard to a public sector coming along and imposing standards? Gabe? By the way, I'm getting very good at identification. I didn't see his face, I saw his hand, and I realized who it was. Your hands are what? Okay, go ahead.
It's not very efficient because you don't give the incentives, for example, in a market solution, you can trade and find efficient solutions based on people's different abilities to abate.
Right. The problem with standards is the only way, and this is another way of saying what Gabe just said, the only way to achieve the efficient outcome is if the government knew all polluters' marginal abatement cost. And they don't. So they're likely to make mistakes when they set standards. The second type of policy is to use incentives associated with taxes, what we call corrective taxes. And the third possibility, which is what Gabe just suggested, namely allowing trading of pollution rights. I'm extending what you said, but that's where his observations were going. So those are the three standard policies that are available. The problem with standards, as I've already indicated, is the public sector, the government doesn't know what the marginal control cost of all firms. Hence, it's very difficult, even though the EPA, for example, would come to a conclusion about what the amount of pollution that's allowable, how are they going to divide that up among all of the sources of pollution. And this takes us to another figure that was in your textbook reading that shows what happens if you get the standard wrong. This is an illustration here where we're looking at the same problem with regard to emission of nitrogen oxide, and we see, once again, the marginal control cost for power plants and the marginal control cost for cars. Now, if the government came along and set a standard for power plants and said, you must abate 6.7 million tons, already, given the prior graph, we know that can't be optimal, right? Straight away, we know it can't be optimal. And what are the consequences of it not being optimal? The consequences are that too many resources are going into abatement. And the deadweight loss associated with those too many resources, we're going from the optimal point on power plants of 2.7 up to 6.7. And if the amount of abatement is going up for power plants by 4 million tons, then the amount of abatement that vehicle cars have to achieve falls by 4 million tons, right? Okay, and when that happens, this light shaded area here is the reduction in costs that are faced by vehicle cars, but this is the total incremental cost associated by power plants, and the difference between those two is a deadweight loss. Okay? That's a deadweight loss in employing resources to control the amount of emissions of nitrogen oxide. Okay, there's a table in your textbook that goes through the standard policies, namely imposing standards, and these are referred to, as we've witnessed a number of times in prior lectures, as command and control approaches. And what this table does is just outline in a qualitative way what the benefits and costs are associated with different types of standards, whether those standards are imposed on emissions, whether they're imposed on inputs, whether they're imposed in terms of some technology standard. For example, any high sulfur coal-burning plants in the United States must use a technology referred to as scrubbers to remove a fair amount of the sulfur from coal before it's burned. Okay? Now, is it possible to achieve some amount of abatement in a cost-effective manner if you don't know each and every individual emitter's marginal cost? Yes. Those take us to the other two policies, namely emission charges and or emission trading. Think for a moment about the chart we put up initially where the optimal incentive was 45 cents per pound, right? How do we know 45 cents? If we're the public sector and we're trying to determine what's going to give us a total abatement of 22.1 million tons of nitrogen oxide, how do we know that 45 cents is going to get us there if we don't know what the marginal costs are? Well, we go through an iterative procedure with regard to setting those prices and seeing where, in fact, the amount of nitrogen oxide that's emitted and what the response rate is of nitrogen oxide to different setting on emission charges. But fundamentally, all we're attempting to do is reflected in this simple graph. What we're attempting to do is find that corrective tax, cap T, that is going to give us the amount of abatement that we seek. And if it turns out, for illustrative purposes, suppose in the simple graph it's not 10 that we want to abate, but suppose it's 8, then quite obviously T is going to be too high. And you go through the process of observing the outcome, changing the corrective tax until you get internal consistency between the tax that's being set and the target that is established by the public sector with regard to the amount of emissions that are acceptable. Okay, coming back to our example of nitrogen oxide and the 45 cents per pound and finding how we would arrive at that point is to come back to the original graph and look at different settings on that particular tax. For illustrative purpose, what happens if the government happened to start not at 45 cents but at a price of 20 cents? Well, now the incentives for the power plant is not to abate very much, right? Because keep in mind the following. The tax is not applied to the amount that the company and the car drivers abate, but instead it's applied to what they don't abate, right? So the tax is imposed on the actual amount of emissions, not the amount that is controlled and or abated. So at 20 cents, we look at the marginal cost. Now the incentives, coming back to one of our core principles in economics, incentives matter. So what this graph says, at 20 cents, the power plants are only going to control 0.9 million tons. That's certainly not going to get us to their optimal share of the amount of emissions, which was what? What was that in the first graph? 2.7, exactly. So they're quite a distance from that. If we continue to increase the tax, at some point we'll get 2.7 for them. Suppose, in contrast, that we started with 60 cents. what happens at 60 cents? Now the power plants are over-abating. Instead of abating the 2.7, which is optimal, they're going to be abating 4.6. And whatever happens with regard to the power plants, the mirror image of that is taking place with regard to the cars. But since their marginal cost of abatement is fairly flat, you get dramatic differences where, in some cases, for illustrative purposes, at 20 cents, the incentives is below their marginal cost. They're not going to do anything, right? They're just going to sit back and say, okay, fair enough. Our cost of abatement is so much larger than what you're going to charge us for our admissions. We're going to respond to this incentive by admitting the full amount. Okay? All right, this is coming back to admission standards, and once again, isolating the correct incentives so one can achieve the most efficient control of pollution. Admission charges clearly are those that can be adjusted, and ultimately you'll reach an equilibrium point, just like when we're looking at willing buyers and sellers in a marketplace in which the market is functioning well, and there is a price that is determined by the market. Now, you may say, gee whiz, why do we have to use taxes? Why can't we just use subsidies? If we want to create incentives for firms to abate and control the amount of pollution, why can't we just offer incentives through subsidies? In a simple context, offering carrots rather than a stick, right? Take the example where the government pays the power plant for abating instead of charging them for admissions. Now, when you stop and think about this for a moment, if the government offered that kind of program, then the company now has another good it can sell. What's the good it can sell? For a positive return. What's the good? The good is reducing the amount of bad, namely abating, so there's less harmful negative externalities through the admissions that would otherwise take place. Let's look at this graphically. Okay, this is a subsidy, and suppose the government makes an initial mistake by offering 93 cents. Okay? If it offers 93 cents, now the power plants will have the incentives to abate well beyond the optimum, namely they will abate 6.7 million tons, and when they do so, the subsidy that they will receive for a subsidy per pound of 93 cents, they'll receive a subsidy of $13.7 billion, and the cost of their abatement will be $7.2 billion, and they'll be able to pocket the difference. Not a bad deal. Now, as a taxpayer, you may not prefer that alternative, but certainly the power plants would find that to be a very positive incentive, which would create more abatement rather than less. Okay, another example is the incentive to innovate. One of the big problems with respect to standards, particularly if they're standards for particular technologies that are pre-specified, it doesn't recognize the possibility of technological progress. New discoveries are made, there's more efficient mechanisms with regard to storage of emissions or products that cause harm to the environment, and here is an instance where suppose initially that there's technological progress that comes along. This is the original marginal cost curve here, original MCA, and this is the new marginal cost of abatement with innovation. Well, straight away, at the old amount that's admitted, the 6.7, there's a 20-cent improvement in the cost that a particular, in this case, power plant would face. Now, under those circumstances, we end up with less admissions taking place because now the optimal point at 93 cents is out at 7.4, which means that the power plants no longer have to pay a tax on this difference, right? Because they're controlling it. So there's no tax that's being imposed upon them. And the black triangle that's here is this ultimate savings from the innovation, and that savings will provide the kind of incentives to adopt the technology resulting from the innovation as reflected on this curve, which is nothing more than a shift. Remember all the discussion about looking at what the new equilibrium is? Is there a shift in the supply schedule? Is it the demand schedule? Is it both? What's the new equilibrium? It's the same story here. Right? Okay. Okay, cost-effective policies. Now let's turn to the third policy, namely admissions trading, in which there are pollution permits that are offered. And if it's going to be effective, it has to satisfy all of the conditions that when we look at property rights that have to be well-defined, particularly in the context of the Coase theorem, remember? Do you recall? And I've specified here on this slide those three basic conditions: exclusivity, transferability, and enforceability. And the presumption is, and moreover, you're not going to have a well-functioning market for pollution rights unless these three conditions are satisfied. And the ultimate equilibrium will be the price for those pollution rights where the total cost of control are minimized. And it can only happen where the marginal control cost for each of the emitters is in equilibrium the same. Let's look at a simple graph illustrating the same point. Coming back to the earlier graph and measuring along the horizontal axis the amount of abatement moving left to right for the first firm and the amount of abatement for the second firm moving right to left. Now, let's stop and look at, suppose initially that firm 1 is abating 8. Firm 2 is abating 7. Tell me, given that factual pattern, tell me, omega, please, what are the incentives, what's the benefit of the bargain between firm 1 and 2 to move away from an abatement of 8 for the first firm and 7 for the second?